Welcome, all of you, to what I call the Daft Punk panel. We tried to get the music, but we couldn't, so think of it off your head. If you have it in your head, I apologize, because you're going to have it in your head for the rest of the day. So we got about 30 minutes to discuss building smarter AI model to reduce compute costs, which is kind of a big topic. And obviously, we're kind of opening up for questions at some point during the discussion. So if you have any question, please introduce yourself and ask your question quickly. But maybe let's try to set the scene in terms of what do we mean, because we've got three different persons with also different perspective. So maybe, Ronald, if I start with you in terms of, can you maybe tell us a bit what happened more on a kind of algorithmic model perspective in terms of what you're saying in terms of AI compute and kind of reducing AI models and reducing those costs?
You're full in already. Okay.
Yeah, let's get in there.
Hello, everyone. Roland, currently at Stanford University. Before that, 20 years in AI. Worked as Chief Data AI Officers in Financial Services Organization. So I know how to call it generate demand on artificial intelligence that actually end up in all your data centers and driving them forward. I'm now moved to Stanford University to focus on the latest things on artificial intelligence and what is happening there. When it comes to the algorithms and what you see in the markets, especially when you talk to the big players, of course, bigger models, multimodal models are getting out there. Bigger models in trillions of parameters getting trained around that one. In parallel, there are other streams from smaller research groups, not that famous ones, they actually say we have to differentiate either for energy efficiency, for accuracy, for consistency of answers, and the way we actually having better ratios between tokens per kilowatt or when it comes to tokens per seconds to run to drive them further. So clearly, you see differentiations in either the hardware design, you see differentiations in the way we're doing the architecture of the AI in itself, and you see differentiation in the way we're using the artificial intelligence in certain solutions by having a more clever way to drive them further. On the hardware designs, besides GPUs and GPU clusters that run in parallel processing, you see a rising special hardware that is optimized for large language models to drive them further. LPUs are something that is still in research. Few other companies are coming up there that actually run, they're optimized for large language models, language processing units, for sequential workloads to drive them further, instead of having parallel processing to drive them on sequential ones. Early stages, things that are currently getting on hardware, as well as wafer scale architectures where you have using the full wafer for the GPU and the analyzers around them. So hardware technologies is something where a lot of VCs are investing and a lot of startups coming in there. And it's an exciting time because that happens across the world. Second, on the architecture in itself, on the AI architecture, you see things arising like, of course, smaller models. And we had just a discussion in the roundtable around that one as well. Smaller models, more specialized models for certain purposes, sometimes running in the data center, sometimes running in the edge, sometimes running between, sometimes running in a collaborative mode, aka federated learning approaches, mixed model approaches to actually drive them further. Really, ensembles, as a data scientist, you would call them ensembles, to run and facilitate certain workloads to drive them further. And you combine that one with things that have been there for the last 20 years but have not used in large language models. From compression, better quantization of the data, you actually, what DeepSeek did, one of the big secret sauces there was simply using 8-bit floating numbers instead of having other kind of byte structures there. And that already achieved a 10% increase of the performance there in efficiency of the models. And you see things like using large language models for AI purposes in combination with other architectures. Especially Meta is a big promoter, and Jan LeCun is a big promoter of more heterogeneous architectures. So you see the rise of so-called neurosymbolic AI, where you combine large language models, brute force approach, with knowledge bases, with logic approaches, with the way you harvest and gather data out of graph databases and actually driving them on forward as well. So you see more efficient ways of driving them on the architecture of the artificial intelligence to drive them further. And then the last thing is, of course, user education and use cases. Because when you think about your own way of using your large language model, your Anthropic, your OpenAI, your Nemo stack, you usually click the the pull down menu, give me the best model that actually has the lowest latency, and that is the one I want to use. In organizations, especially the one I was running before, you don't want to have everyone using the biggest model that actually consumes the most number of tokens. You want to have the reasonable number of tokens and the reasonable performance for model for the use case and the intent that is there. So things like model routing, pre-prompting, using smaller models and directing either the user or the prompt in a certain direction is already helping in that way. All that said, there's still huge increasing demands when you see about the large language models and the multimodal features there. When you think about 2 years back, typical size of tokens for a prompt was a few hundred tokens, and you run a proper prompt there, maybe 1,000. When you see the latest announcement from last week, the Google I/O conference, have somebody seen Google Flow? The way of actually having continuous integration on video streams, and each video stream of these 600 frames, around 2 million tokens, one after the other, that is actually really driving data center consumptions and demand up there. So the more we go into real-time voice translation, going into video, with all the things that I said there, there's still increasing demand curve to drive them further.
So quite a lot.
Quite a lot. Quite a lot is happening there.
Very good to get in there. So let's be moving with you, Garash, in terms of Ronald's kind of mentioned in terms of a lot of startups and a lot of investment going there. So from your perspective, what is happening from an investment side of things? Because everybody is investing quite a lot. I've kind of mentioned the 9 figures we're seeing from the big companies and from big governments, and even getting into 10 figures because it's starting talking about trillions. But even on kind of a lower scale, everybody's investing quite a lot. So what have you seen?
Absolutely. Let me give a quick context. Hi, everyone. Gayatri, you can call me G. If it's easier, just the letter G. I'm with Hitachi Ventures, the corporate venture arm of Hitachi, but we're set up more like a traditional venture fund with Hitachi as a single LP. We manage about $1 billion in AUM. In terms of areas we focus on, we kind of reflect the areas that Hitachi operates in. We look at industrial, we look at life sciences, environment, so green and mobility. And horizontally, we look at technologies that enable digital transformation. And of course, today that is largely driven by AI. So we invest up and down the stack from infrastructure all the way to the application layer. If I have to say what's the theme of the day right now in the investment, it's agentic AI. It started a few years ago. But interestingly enough, what I would like to sort of talk about is also around, this year, everyone talks about physical AI as well. Roland, you just talked about multimodal data sets. So we actually invested in a company 2 years ago whose Twitter handle happens to be physical AI when they founded. So the idea being today, largely multimodal data sets also mean just text, video, images. When you look at industrial setting, that also needs to incorporate sensor data or real-time series data. So this company actually does that. So we've been very selective in what areas we invest in. So we didn't want to go after the foundation model craze, but this is a specific area where we felt 2 years ago that language is only one part of the problem. 80% of our daily interaction happens with other people, with real world environment and situations. So we wanted to tap into that, what happens in that sector, especially when you look at manufacturing use cases. The reason I call that out is that's becoming a very hot trend right now. So there's a lot of talk around physical AI. And interestingly, most physical AI references are also just with robotics, and you see a lot around humanoid. And I think that's still being very short-sighted, and you're only looking at a small sliver of use cases. So physical AI, if you look at a manufacturing setting, robotics is only a small percent, right? A lot of it happens through big instruments and appliances, especially if you look at some of the semiconductor segment. I used to work at Micron before, and they have the concept of like lights out factory, right? There's no need for light because the whole thing's automated from end to end, but that's not normal in traditional discrete processing, manufacturing floors and so on. So that's a big theme for us. Of course, agentic AI, we've done a couple in that area. And when we talk about models being very efficient, you need, from an agentic AI standpoint, that's super important because, like Roland pointed out, you can't just use the biggest models. So we've invested in a company called Emma. They just announced a model with Emma Fusion where they use mixture of experts. But at a task level, they decompose what a task needs to be, and then they pick and choose models to optimize for performance, latency, and accuracy. And they just published their result where they showed 94-point-something% accuracy, whereas more traditional models are more at 91%. So by using this mixture of experts, they're able to not only provide higher performance, but also at a lower cost, right? We invested in this company in the physical AI realm. They are optimizing by doing pre-training. And then when it comes to real life factory setting, there's pretty much zero-shot or one-shot learning. And even small language models these days are like 3 billion parameters, right? So we are looking at, can there be models that are even smaller than that? We have invested in a company called RC that does small language modeling or generates small language models. We see that as very critical for industrial segments where people don't want their, or think their data is very unique and specialized, and they don't want to give that access to that data outside. And frankly, if you don't need that large generalized, if you're not going to ask your model for what's the weather in Copenhagen today, you don't need a generalized model. You need something very fine-tuned for the use case that you're working on. So they do special kind of training. One is called selective layer training. So if your model, they will pick the ones with the highest signal to noise ratio and optimize based on that. So not every layer gets trained in your small language model, but selectively picking and choosing where you're doing it. They have distillation as a part of their, model compression as well. So by using techniques like that, they're able to bring down the model sizes to still, I think the smallest is still in the hundreds of millions of parameters. But we did look at another company that's looking at really small, like 10 million type models that can go in phones, for instance. So I talked about the model layer. I talked about sort of the multimodal foundation and agentic AI. But quickly, I think there's a lot to be said around infrastructure, and I'm sure David will talk about it. We are actively looking at what can be done at the infrastructure layer to also make AI more energy efficient. A big theme for us is around, okay, it's not just compute. Having worked at companies like Micron before, you know that you may have heard about terms like memory bandwidth wall. That's driven largely by, transfer the data back and forth between the compute. So networking becomes important when you're talking about large data sets. Storage becomes important. And how do you enable these? So we have looked at all parts of the stack. We've invested in the networking layer. We've invested in a company called Vecca that does software-defined storage to optimize your GPU utilization. And finally, we've invested in a company that does optical interconnects to enable copper-like cost, but fiber-like performance. So that's something that we think will be critical as well.
So again, quite a lot on the investment side. And you gave me the perfect segue to ask David about infrastructure, because that's what I wanted to ask him. So from your perspective as a CTO, what are you seeing on the infrastructure side?
Yeah, of course. When you speak about AI optimization, it really needs to be viewed as a full stack optimization. So there's tons of examples that the guys here have kind of walked through in terms of how to optimize the algorithmic side and how to implement the optimized inference and training side of things. But as you look at the entire stack, and that's what we're doing kind of at Nscale, is we've over 1.3 gigawatts of capacity that we're bringing online over the next while, and we're taking a look out in the roadmap of power densities and efficiencies and what the future of machine-driven workloads looks like, and building modular architectures for those workloads. So in an application, when you're running kind of a synchronous a collective across the system, if there's one component in the entire infrastructure which is running either at a lower clock speed or slightly kind of in a degraded mode, that slows up the entire infrastructure. And of course, as these clusters scale from thousands, tens of thousands, and even hundreds of thousands of GPUs, the likelihood of individual components being either degraded or crashing or failing during that execution, has a severe impact in terms of the uptime of the infrastructure. So we look at, there's been great talks this morning around supercomputing platforms. I mean, my own history is I've worked for 20 years building kind of the largest top 500 scale supercomputers as well. Prior to that, I was a researcher in distributed genetic algorithms, but unfortunately I had to kind of do all that on Pentium 3s instead of GPUs. So we didn't quite have the luxury of the compute infrastructure you have today. But seeing all of this come together is a hugely exciting time in the industry. And having to optimize every single layer of that is hugely important as well. On the cooling side, as the team from Lenovo were saying earlier, if the GPUs aren't running at the kind of optimal temperatures, individual core speeds begin to clock down and slow things down. There was a great paper from Meta when they were training their Llama models in terms of the uptime and frequency of component failures that they observed during a kind of a 90-day training period. What we're also doing as well to kind of combat that is build resilience into the platform. So they were having to checkpoint and restart every couple of hours because of either fabric failures or GPU memory failures. So we're kind of, again, looking at the fabric as well as the mechanism for scaling applications and workloads and building telemetry, observability, graceful failover across different links, looking into deep observation into like the Q-pair links across the NV fabric and rerouting traffic across it instead of checkpointing. So the application will continue to run instead of completely checkpointing and restarting. And again, all these compound effects really do help in terms of lower that cost per token. The other kind of humorous thing I've kind of observed is we seem to have a very mixed group of users and consumers of AI. We've got the guys who've come in from the supercomputing world, and they're looking at very low-level optimizations of kernels and really kind of fine-tuning in low-level code for individual architectures. And with people that are taking very high-level abstract frameworks and just assuming that they do very good placement and NUMA efficiency of the entire platform. So another thing we're kind of looking at is how do we create a feedback loop for all users where we can give them full observability and telemetry into the entire application resource consumption so that they can see, as Andy was saying earlier, HPC is the kind of dark art of just moving bottlenecks around system architectures. But how do you present that information back to the end users so that they have an understanding of, okay, my application is being throttled based on the bandwidth, based on the memory clock wall, based on the storage input, based on nickel parameters across the fabric. Being able to provide all of these resource consumption utilization metrics again allows end users then to right size the individual GPUs and right size the infrastructure for either the training or inference workload that they're consuming. And then just on a final point to that as well, like we see the future, we're going to be building out numerous different cloud regions across Europe, across the US. How do we put intelligent routing mechanisms in front of our services so that we can go and select the most cost-effective infrastructure for the workload at hand? Everything's not just going to go straight to the latest generation of GPU infrastructure. If there's considerations around latency, throughput, and batching of workloads, we can do intelligent rerouting to the most cost-effective component in the infrastructure as part of a heterogeneous setup where we can have previous generation infrastructure abstracted away behind intelligent mechanisms and intelligent schedulers to ensure that we're promoting the most cost-effective use of the environment then as well. So it's it's a hugely complex stack, and we're hugely excited to be working as part of that infrastructure layer at Nscale.
So I want to, before opening up, I want to ask you a question because you will mention a lot of different things. But it's good. I'm not saying that as criticism, but basically, if you're an end user and you're seeing that industry, which is moving super quickly, innovating super quickly, implementation is also very, very quick. And you're kind of looking, okay, what do I need to do or do I not get left behind? So I kind of want to ask a quick question in terms of, you talk about end users to some extent, and I think they're all asking the similar question. So how can you make sure that you stay basically at the top or on the edge or kind of the most advanced possible? What would be kind of the 1, 2, 3 takeaways you would say in terms of, okay, this is what you need to think about if you want to really stay and not be left behind? So maybe David, I'll start with you and then we'll go around.
So, it's not just the responsibility of the user to maintain it. I think service providers need to stay at the cutting edge of technology as well. And when new models are released, new capabilities are released, new frameworks are released, try and have them integrated into an easy to consume environment so that it becomes easier to consume for end users and democratize access. The pace of innovation in this industry is something I've never seen before. It's incredible how quickly frameworks come and go and how quickly models come and then they're overtaken by other ones. So like we're, as part of the stack we're building, we have the infrastructure as a service layer where we always try and get the latest generation infrastructure to market as quickly as possible. And we're kind of pre-planning 18 months in advance data center builds to ensure that we're ready with the latest infrastructure so that you have the performance. And again, additional capabilities like the lower precision capabilities like FP4 coming in the Grace Blackwell platform, which again helps reduce down the kind of cost of compute time. But also we've been building serverless environments where we can actually just expose APIs and secure enclaves for end users where they can come in and consume the very latest generation of whether it's DeepSeek, Qwen, Llama, these models, and they can come in and fine tune based on those models and making them accessible for the end users as well. So it's an industry initiative. Everyone is collaborating to try and make the pace of innovation increase even further. We're contributing towards that by making sure that we have the latest technologies available, deeply integrated, performance optimized. But yeah, the end user has an awful lot of work to do as well to keep up.
Not easy. Guarantee.
Sure. I'd like to add a couple of points, much more practical, right? So one is around first data hygiene. I think a lot of people don't have the basic infrastructure to make the data accessible for the AI models. So making sure that you actually have that, understanding the data lineage, data quality. So it's like essentially the output quality depends on the input quality. So it's garbage in, garbage out. So making sure that your systems are actually ready for AI, I think is the first and most important thing. And most companies are beginning to realize the importance, because before, I think most of the AI implementations were siloed, but when you're trying to apply generalized LLMs and so on, then you need to really think more holistically from end to end. Where's your data coming from? What's the quality of the data and so on? The other thing that I'm also seeing is there's a lot of whiplash effect because of the pace of innovation. Couple of years ago, everyone went, and when generative AI became popular, everyone went and bought their own GPUs. They thought they could do their own thing. And pretty quickly, they realized that it's not the case, because then they have to pause and see every change that's happening, and it's hard for them to keep up with that change. So really, I actually think that the amount of innovation in the open source is also makes everyone feel like they can try things on their own. It's easy to do things in a sandbox environment, in a non-production environment, but the minute you have to take that from a sandbox to a production environment, that now you're talking whole other different ball game. I'll give a very simple example. We did a website refresh and we wanted to, of course, use AI. One of our senior partners said, let's use AI on our website instead of the boring chatbot, right? So maybe people can ask questions and they'll get answers about Hitachi Ventures. And oh my God, it spews crap most of the time right now, right? So we turned off that feature because we don't want to be, we don't want to get more spam than we already do at this point. So I think not everything is ready for prime time. So understanding sort of where your limitations, doing a basic sort of a refresh of where you are, honestly, and then thinking about who you will work with to make the AI journey a reality, I think is very much important, because it sets the ground rule for how you're going to move forward.
And Roland, from your perspective.
So I had more time to think, so make it quick. Three things. Number one, think about the assets you invest in, integratability, reversibility. Talk to your CFOs, because this is the quickest write-off you can imagine. All the hardware actually from the past, actually getting out there on all levels of the stack. And this is why, David, you mentioned that one, from really the hardware up to the models and the integrations there. Second thing, look left and right. What are the possibilities in hardware, in infrastructure, in architecture? Don't be dogmatic. This is the main thing, because there are bits and pieces here and there that can be reused from other spaces, and things what we have learned in the past, like other kind of data storages that make things easier, for instance. And third one, get maybe people that understand end-to-end. Usually we are split into different layers of the stack. And with the complexity you have there, you need people that understand from the application layer, what is the solution, what my clients or my clients want to run, down to the data center. What does that one mean? And how does that one run over time? And how does that one evolve over time? And usually we are too much distributed. And before a data scientist talk to somebody in a data center, there's long time gone before that one happens. And you have to bring these people together because it will get more complex. That means as well, bring your clients in to actually say what is happening there. And that helps also maybe to adjust certain contracts, certain way of working, certain collaborations.
Very good. Do we have any questions? Are you being shy because I have the name of a serial killer?
Ooh.
I know. There's one over there. You see, I say that and all of a sudden everybody puts their hand up. It always works.
Thank you. My name is Sean Gifford. I'm a PhD student at DTU, focusing on quantum machine learning and generative AI. So I have a question about hallucinations. Do you guys think that the reduction in compute cost will then further lead to more hallucinations? And how do you think we should deal with hallucinations moving into the future? Thank you.
Who wants to take that?
Easy one to do.
Go for it.
Go for it. Okay. Worked in financial services before in highly regulated spaces, leveraging artificial intelligence. Our answer is always, what is the problem and can we cope with a hallucination there? So do you have a risk approach usually in decisions? Financial services, when it comes to money flows, when it comes to underwriting, when it comes to fraud detection, don't have that big hallucinations, okay? Then apply architectures that can cope with hallucinations, not only grounding of large language models, but also having, for instance, possibilities to tap into knowledge graphs and knowledge bases that actually have the ground truth de facto almost hardwired there. And this opens up completely different alleys of the way you're driving your architecture. Currently, most of the people say GPUs, large language model, data in, input out. And that is not the case. You actually have to think more versatile in the way you actually apply that one there. And there are mechanisms to drive that one. For instance, currently you have a renaissance of logic programming, really a renaissance on that one, something that nobody did for the last 30 years. And you combine that one with the large language models that gives you the definitive clear answers in natural language. So you get best of both worlds. And this is the architectures you will see more and more rising there. And they are more cost efficient. That comes on top. Way more cost efficient compared to just using the AKA bazooka large language model.
Any other questions? Gentleman over there. Where's the mic?
Run.
Sorry, Alex. Making you run.
Hi, thank you. I'm Nathan Corder. I'm Director of Research at Mind Foundry, an applied AI company. And I had actually a very similar question to the previous one, which I thought was excellent, but slightly more general. There was a big problem with how will we safeguard these AI models that go out into the world. I wonder if you could comment about what role the AI compute part of the stack could play in that process.
Yeah, look, I can take an initial stab. I mean, it's hallucinations are one of the, I guess, inherent traits of models. Sometimes they're a good thing for creativity. Other times when they're making mission critical decisions, you definitely don't want that. We've seen kind of, the evolution of test time compute where people are actually bringing additional models to sanity check the outputs, verify them, perform reinforcement learning on the model to continue to fine tune it. And eventually, once you're able to kind of define parameters which are acceptable outputs, over time those hallucinations kind of reduce down. So I think it's interesting in terms of the test time compute that you can allocate to this to sanity check, and of course if it's a coding type problem, you have a definite ability to apply a logic layer, and it's a very binary answer whether it's a functioning, a working piece of code or functioning piece of code as opposed to a broken one. And then of course you have the kind of the mixture of experts model where you can actually put multiple different models side by side, compare outputs, and then select the most appropriate one then for yourselves. So as we progress down the path of continuous compute, infinite compute, we can apply more compute and test time compute to the outputs to ensure they're satisfactory, they're accurate, they're safe, they're unbiased, and again data has a point in feeding into this as well, ensuring that you fine tune based on the data sets which are most suitable for your specific workload and your kind of business environment to ensure you get the right kind of outputs as well. So it's not a solved problem. There's lots of active research on it, but I think the additional kind of architectures that are emerging and compute capabilities that are emerging will help reduce that over time.
Yeah, there's multiple conversations from an investment standpoint. We are looking at things like model security. We are looking at non-human identity with the rise of agentic AI. Now you're going to have agents operating as humans in the future. What does that mean? What kind of access do they have, right? Again, I think to Roland's point earlier about it's not going to be purely LLM based. We think it's going to be a mixture of knowing when to use what is going to be most important. As David pointed out, hallucination is more a feature than than a problem. But in certain financial sectors or healthcare, you don't want your models hallucinating. So we've actually invested in a company called Trustwise that's building sort of that trust layer. And kind of API based, it can tell you, it compares against the corpus of the company data. And if it doesn't have the information, being able to say, no, we don't know the answer, or where it's not making up stuff. Another thing that I also learned is in a financial sector, for instance, if there's a court case and you actually have to be able to replicate, LLMs are not capable of replication. The whole point is they are non-deterministic. But the idea that you create kind of a logging system where you, based on the prompts and the context of the prompt, you understand what kind of responses are being generated repeatedly so that you can be more consistent. So there is some level of repeatability in the model, right? So I think LLMs are not a one-size-fits-all, and you shouldn't be throwing it for every problem. And knowing where to use what kind of models are going to be super important, I think, going forward.
And we're flashing red, so I think we're going to have to leave it there. So thank you very much to the three of you for what has been a very, very good panel. Thank you very much.
Thank you.